Today's my lecture topic is rocket propellant properties. It is important to distinguish between the characteristics and properties of the liquid propellants, that is the fuel and oxidizer liquids in their unreached condition, and the properties of the hot gas mixture which result from the reaction in the combustion chamber. The chemical nature of the liquid propellants determine the properties and the characteristics of both of these types. Propellant properties are some of the economic factors. First one is economic factors. Availability in large quantity and a low cost are very important consideration in the selection of propellant. In military applications, consideration has to be given to logistics of production, supply and other possible military uses. The production process should be simple, requiring only simple chemical equipment and available raw materials. The performance can be compared on the basis of the specific impulse, the effective exhaust velocity, the characteristic exhaust velocity, the specific propellant consumption, ideal exhaust velocity or other parameters. They have been expressed and the impulse, the specific impulse and the exhaust velocity and the specific heat ratio and the combustion temperature molecularly all are described. Very often the performance is expressed in terms of flight performance parameters for a given rocket application. Here the density as well as the specific impulse usually enters into a complex flight reaction. The common physical hazards in the propellants and the liquid propellants is mainly the corrosion, explosion hazard, fire hazard, toxicity. These are the main common physical hazards available in the liquid propellant. Corrosion. Various propellants such as nitric acid and hydrogen peroxide have to be handled in containers and pipelines of specific vessel materials. If the propellant were permitted to become contaminated with corrosion products, the physical and chemical products of the propellant would change sufficiently to make it unsuitable for rocket operation. Contact with the skin causes very serious burns. The corrosion of the gaseous reaction products is important in application in which the reaction products are likely to damage structure and parts of the vehicle. Second one is explosion hazard. Some propellants such as hydrogen peroxide and nitromethane are unstable and tend to detonate under certain conditions of impurities, temperature and shock. Third one is fire hazard. Many oxidizers will start chemical reactions with a large variety of organic compounds. Nitric and hydrogen peroxide will react spontaneously with many organic substances. Most of the fuels are readily ignitable when exposed to air and heat. Next one is toxicity. Many propellants are toxic or poisonous, and the special precautions have to be taken to protect personnel. Aniline, for example, is poisonous if it contacts the skin. The corrosion, explosion and fire hazards of many propellants put severe limitations on the materials, the handling and the design of rocket-propelled vehicles. Not only is the rocket system itself exposed to the hazardous propellant, but adjacent structural parts and electrical and other vehicle equipment have to be properly protected against the effects of possible leaks, fumes and propellant accumulation within the rocket engine compartment. Next one is desirable physical properties. Low freezing point. This permits the propellant operations of rockets in cold weather. The addition of small amounts of special chemicals have been found to help depress the freezing point of liquid propellants, which solidify readily at a relatively high temperature. Next one is high specific gravity. In order to accommodate a large weight of propellants in a given vehicle tank, a dense propellant is required.